Okay, so your test will be week 8, as I announced in the canvas. Week 8, Wednesday morning, 8 to 10, at meeting room number 2. Request go in the glass door, left hand side. For lab, most of you, no problem. But for those who miss it, you need to repeat this session next class. The lab announcement, that one is for international student. There's one international student missing. Okay. Now, today we're going into chapter 3. Will be part of your test 1. Your test 1 have two questions. So later I'll brief you guys on the test after today's lecture. So I will end the class before 9:30. So just remember to ask me what is the tips or what is the scope for your test 1. Okay. So recap previously what you learned in chapter 1. Chapter 1, you learn about S, V, A, and T. You learn about definition, V equal to ds dt, A equal to dv dt, and equal to ds squared dt. Combine these two, you freeze the time, you get A ds equal to V dv. Okay, then there's a five graph, VT, AT, ST, and so on. Okay, then you learn about 3 Newton equation. V equal to what? V squared to what? Delta S equal to what? Okay, there are 3 Newton equation, but this one, acceleration must be constant. Then, chapter 2. Okay, chapter 1, you learn about 2 motion. One is linear, one is collinear. Linear, you use X and Y. Collinear, you use normal and tangent. Okay. So here, you always, all the parameter we use here, they are vector. So vector, you need to find the vector, you square the other subvector, and there's an angle that you can find. You always use tangent something, y and x, something like that. Okay, chapter 2, what we learn? Chapter 2, we only learn one equation, which is all the force equal to ma. Okay. Now, then you learn about free body diagram and kinetic diagram. And once you draw this one, you solve based on direction. If it is linear, then you split into x and y. Then you do all the force in x equal to max, all the force in y equal to may. But if a collinear, then you have normal and tangent direction. So all the force in normal equal to man, all the force T equal to mat. And chapter 2, you deal with 4 kind of force: external force, weight, friction force, and normal. Okay. Now, then the motion, it depends. The motion, you only have 2, linear or collinear motion. Okay. So this basically is what chapter 2 about. The difficult part is some of you might miss the Newton because you forget that contact surface have normal force, right? Now today we'll go into chapter 3. Chapter 3 is an application of chapter 1 and chapter 2, where we look at work. Okay, we look at work. Okay. Okay. We look at work and then we look at energy. So just to sum up what we're going to do today is you're going to learn only two main equation. What is work? What is work? Work only deal with two parameter, which is force and distance traveled. Okay, so if an object deal with the force, I'll write something on the whiteboard now. So force and the distance traveled. Combination of force and distance, we call it work, is the force multiplied by distance traveled. Okay, and what is the important thing for the magnitude of these two vectors? They must be parallel, then only can create work. Okay, the direction for force and displacement must be parallel. So no matter how the question asks you, try to stick to the surface. I'll give you hints already. When you see question in coming test 1, your force and distance, try to fix together so that they move parallel. Then they create work. Understand? In what circumstances there is no work? When your force is perpendicular to the distance. When the force and the distance traveled is perpendicular, no work. When the force go parallel, there is a work. Okay, there is an angle. Remember, angle, force with the angle, you can split into y and x. The one that x with the distance parallel create work. The one that perpendicular, it will give you zero work. Remember that. So this is the key for this chapter. Now, then for energy, I just summarize for the chapter 3. Energy, you only deal with two energy only that you learn in your physics, which is kinetic energy and potential energy. Okay, kinetic energy, K, E, only deal with half mv square. Only deal with two parameters, mass and velocity. If the question do not give you velocity, where you get it? You get it from chapter 1 or chapter 2. You find it from the force or you find it from the derivation. Yeah. Okay. Potential energy. This one deal with mgh. Deal with mass, gravity, and the height. What is important here? Later I will mention in the lesson. MGH, this one you have to be careful on your reference. Some give you positive potential, some give you negative potential, depending on your starting point and your datum. Okay, so basically these are the three equations in chapter 3. When a question asks you conservative, use the conservation of energy. What does it mean? It means you conserve the energy, means there's no loss of energy, means you sum all the energy equals 0. Means these two, it depends on the scenario. So if the particles or the vehicles have velocity, then it should have kinetics. If the vehicle do not change altitude, do not change h, then no PE, no potential energy. But if the object change altitude based on the datum, then you have a combine of these two. You have to read carefully the question. You have to see, does the object move or not? Does the object change location or not? Okay, so then this is the thing. Power and efficiency is the ratio of input and output. You always compare with your input, right? Okay, so right here, efficiency equal to what is your input compared to your output. It depends, huh? So efficiency, you can compare energy, you can compare forces, you can compare work, and so on, huh? Work is the energy, huh? Work is joule. And if you take force multiplied by distance, force is Newton, S is meter, so Newton meter is actually is joule. It's energy. Again, remember the direction. As long as your force and distance go parallel, they create work. And then when they reach 90 degrees of each other, no work done. Remember that one. Okay. You start to go into a deeper and deeper, but if you understand, you can absorb the thing I write on whiteboard. You already understand what is chapter 3. Okay. Now, this one is just a derivation of equation. Let's say you have particles moving along the blue circles, blue pathway, and with the center of from this cross, okay, with the distance r and r. When you see r, it means it's a collinear motion. So collinear motion, you know that when it's curved, where is the center? Center pointing in. Okay. So when there's a force acting on this object along the path, right? So this is a vector. So if this particle move from here to here, so the distance traveled from this point to this point, you give you ds, but there's a change of radius of this one. Okay. But we can simplify by using what you learn in your mathematics. We are using radian S and R. So your S equal to R theta. This is radian. So when you use radian degree, you can link your circumference with the angle traveled. Okay, so this one you read, but what is important, we're going to derive what is work equation. Okay, now the work done by the force is the work done by the force is because the distance traveled. So again, the formula we use for work is U, capital U, du or capital U. So again, I already explained just now. What is work? Work is force multiplied by the parallel distance or the surface. Both must be parallel. So it can be force cos theta or ds cos theta, as long as the two parallel. But I would highly recommend you always referring to the surface because surface never change. Okay, so this one you cos it, your force will go parallel to the distance traveled. Yeah. So if you sine it, then 0 lah. Because sine, you get a perpendicular force and the distance. Okay. So this is the first equation that just to introduce you how the work done in the particles with motion. Okay. All right. Now again, there is a appendix in your canvas, appendix B. Go and download and read the appendix. It's about vector dot product, how to do dot products in the vector. Okay, so if you take A dot B means you can write in your vector form. You take the magnitude of A vector multiplied by magnitude of B vector cos theta. Okay, so again, how to find A magnitude? You square anything inside there, square root. Here also same. B can be x on y, I and ijk. So you just square root, you get the magnitude of B. Then you cos the theta, right? So same. If you use the cross product like you see on the here, so ds cos theta, you can write as dr. Okay, can write. Okay, so this basically is just tell you these two statements that you see on the screen here. It just basically tell you as long as the force and distance go parallel, they create work. Okay, so this one it takes time to digest a bit from the statement or from the text here. But basically, as long as your force go parallel with the first surface, it give you work. And for your working in your coming test or final exam, use capital U as energy. Awesome. Capital U for work. For work. Right. Now because it's a vector, you deal with vector. Vector have direction. So if it's the vector from 0 to 89.999, not 90 degree, 90 degree you get 0. So there's no dash here. Okay. So from 0 to 89.999 degree, you will get a positive work. Okay, you get a positive work. Means it moves along the surface. If the motion is going there, the distance traveled is that direction. The force going same direction with the motion, with the distance traveled, then it gives you positive work. If the force go oppose the distance, if the object go this way, but the force go this way, it gives you negative work because vector. So this one you need to be careful a bit, positive, negative. You're dealing with vector. Right. So this is another statement. So again, cannot be 90 degree. 90 degree give you 0 work because of this equation. Cos 90 0. Cos 0 1. So cannot be. So tell you that one. All right. This one is read lah. So force multiplied by distance is Newton meter equivalent to Joule. Equivalent to Joule. Okay. So if you want to calculate a particle travel on a path, on a curve, what you do? You do integration. Okay, you do integration. Work from position 1 to 2 equal to integration of position 1 to position 2 f dot dr. This is on a curve motion. Then you use dr. Okay, so basically dr is the distance traveled lah. Okay. So or you can change dr with the ds because dr is a polar coordinate. We rarely use polar coordinate. We will change polar coordinate dr into cos theta ds. Okay, so remember this dr, we change it to ds and then cos it. So if you do integration, this is the area on the graph. It's actually area on the graph by plotting f cos theta versus distance traveled. Okay, so but if you cannot imagine this one is still okay, but what is important is that when you see a curve motion, you need to do integration. Okay. All right. All right. Now this is this graph is because it's moved in a curve motion, so there's a change of forces. What happens if the object move in a linear motion? You have two kind of motion, one linear, one collinear. So if the object move in collinear, you will get a constant value when the object move parallel to the surface, especially the component of force that is parallel to the surface. If you see this diagram, you need to split the F sub C into X direction and Y direction. So you know that Y direction is 90 degree, cannot create work. So the only magnitude you have to generate work is F sub C cos theta along with the distance traveled. Then this magnitude with the blue line will create work. So the product of the work is the one that highlight in the graph. Right. So again, chapter 3, I won't ask you to plot graph. Don't worry. Only chapter 1, I will ask you to plot graph. Okay. But anyway, it's still repeating the same concept. Work equal to force that go parallel with the distance. Yeah. So this is just a derivation of the integration. Okay. Okay. Now, this is move along the straight line. If the force move in a straight line, normally we'll use this equation. Okay, work from position 1 to position 2, you'll use this integration, or you use F cos theta, distance traveled by the thing. Or you can't remember this one, you just split the force, then go along the surface. It's okay, you cannot remember the yellow color equation, but your free body diagram is very important. Always split your force, go parallel with the surface, means you split your vector of your force into y and x direction. Then the y direction, you just mark across there because it do not generate work. Then you focus on the x direction with the force that go parallel with the surface. That one give you work. All right. Now let's look at weight or the pulling of acceleration gravity. That every object on this earth will have mass. Mass, when you have a gravitational force, you give you weight. So where is the direction of weight? Always go down, right? So the weight go down. Again, now we focus on the work. If the flat surface is go this way, very flat, then the weight always go down like that, right? So does it create work? No, because the force and the surface is parallel. What happens if the object drop like that? It create work. Create work. Okay, so then if they slanted like that, also do work. Okay. So as long as 90 degree cannot. Okay. All right. Now, this is a derivation of that object. Okay. So, okay, again, this one, just now, the object drop like that to work. If the object do like this, do not do work. It's still pulling down like that, 90 degree, do not go work. But if the object do like that, then it do work. Okay, this is a derivation of the three-dimensional position. So it just tell you that you just split your R or position into I, J, and K, X, Y, Z. Then your W will be pointing down. You split into vector, which go down negative J. And how you calculate work? You take force multiplied by distance. Force multiply the distance. So basically you take WdR, then you get work. So work equal to integration of force dr. So dr, you integrate R1, R2, F dot dr. So basically is you can pull your force out. Right? You can pull your force out and then do the integration. So this is just a vector. You go home and do your vector homework. I multiply by J, I multiply by J, you get 0. If you don't understand I and J basically they are perpendicular. So IJ, you get 0. If it's II or JJ, KK, then give you value. Okay. So at the end, you only get dy. You change to, it's the same as integrating your y. Okay, your r, this one you can change to y because other direction give you 0. Because your x direction, your z direction, all perpendicular to your force. W is pointing down. So there's only one that deal with the work is the same direction of the work, the force. So in this one, we only have y and w. Okay. Again, I won't ask you to derive the equation. Important is still go back to the thing. So here, work done by the force, work done by the gravity W in this case is minus. The work is minus because work and change of y, because in this case the object is going up. The object is going up. So the work and the distance traveled is opposite direction. Then you give negative work. That is the concept lah. As long as both go same direction, give you positive. Opposite direction, give you negative work. That is the concept. Okay. Right. So this one I already explained. Okay. We are done with the weight. Now we go into spring force. Now spring force also same. Spring force, you need to recall how to get spring force for the spring. You take spring coefficient, multiply by distance traveled, right? You get spring force. So same. All right. Now how to get the force? Okay. Now, in this case, you focus on the object. So you know that if you press this is the datum, So if during unstressed, your x equal to 0, right? Go to 0. But when you press the particle in, okay, you press the particle in. You focus on the object. You are the object. This is in front of you is the spring. So when you move forward, you are pressing the spring, right? Now focus on yourself, you're the particles. What do you feel on your body? What do you feel? The force pressing in or out? Pressing in, right? In your body. Press in your body, right? So the force is going back, but your distance, your distance or travel is in front. So what is the work done? Positive, negative? Negative. So you have to think something like that. So you have to look at the object, not at the spring. Like you have to feel yourself. What are the force that I feel if I'm standing in front of the spring? So if I move forward, then the force is pressing in, so the force is going back or pressing this way direction, but you are moving forward. So these two actually are opposite direction. So you get negative work. Okay, now we change the scenario. If the spring attached to your body and you move backwards, do you feel? Pulling out, right? So the force is going out, but the distance is going back. So again, two vector is opposite direction. No matter you walk front, walk back, you get negative work for spring. Make sense? This concept, you once you understand, you won't confuse when the question gives you spring problems. Okay, force and distance, when they go parallel, they give positive value for work. When they go opposite, then you get negative value. So for spring, always imagine yourself, you are the object. Then you try to imagine where is the direction of the force. Where does you work? Do you walk in front or go back? This one, when you do the logic thinking, then you should able to understand why suddenly spring become negative, the work, because the two direction is different. The two vector for force and distance travel is different. Okay, now again, we already assume you know how to calculate spring force in statics, right? You have seen statics in the spring in the statics module. So how to calculate spring? Spring F S sub S means for spring equal to spring coefficient K and distance traveled by the spring, right? Spring force equal to spring coefficient multiplied by the distance traveled by the spring. So minus Ks ds. So you have du. The next step is to do integration. So integrate one side, integrate another side. So you have s integrate ds. What you get? S squared divided by 2. Right? You integrate this side, you get s squared divided by 2. So you will be getting this one. You're getting this equation. So for spring, you can either memorize or you can derive from the orange color. Okay, so for spring, the general equation you derive is half ks square, the final position minus the early position. Yeah. So this for spring. So for chapter 3, just now what we seen particle, the force, the normal force on the object. Second one, we look at the weight effect on the energy or on the work, and or the W, the weight. The third one is the spring force. Then chapter 3 will combine these 3 components and put into one question. It's either ask you spring problems, ask you weight problems, or ask you external force problems. These 3, Okay. So this one is just a graph presentation on what is the energy if you plot force versus distance traveled. Okay. Okay. So this one, just need to highlight is work done by the spring always negative. It's always take away energy or release. I mean you consume energy lah. Consume energy. Okay. All right. Let's look at example 1. Right. Now we still keep applying. What is work? Work is force go parallel with the work. You go parallel with the distance traveled, it gives you positive work. If two vector, the vector force and distance traveled is negative, is opposite, then you get negative work. Okay, let's look at example 1. So you have a block with a spring, and it tell you the initial velocity v. Right, rest on a smooth inline. You see the smooth means no friction. No friction. So if the spring originally stretched 0.5, determine total work done by all the force acting on the block when a horizontal force 400 Newton push the block up the plane 2 meters. Okay. So if you look at this diagram, so initially it was push 0.5, means you charge the spring already. Then you let go, it will go up. Okay. So it was charged and then it was pushed by 40. So you're given the spring coefficient 30 Newton per meter. Initial position means you load the thing, and then you have an external force still pushing from here. So you push and go up. Okay, push the block up. The plane S equal to 2 meter. Means on the surface here it moves 2 meter. On the surface here it moves 2 meter. So I will always recommend you follow the surface rather than the force. So split all your force into this surface direction. Okay, or you can maintain forces but split your distance traveled in this direction. Okay, so that your vector for P and your distance traveled from here to here is the same direction. Perpendicular, we doesn't care because perpendicular give you 0 work. Yeah. All right. So these two information just to confuse you actually. Just to pull away your attention. The sine 2 sine 30 and 2 cos 30. This one is just to confuse you. And It depends on whether you want to use or not, right? Okay, you draw free body diagram. So chapter 3 also continue draw free body diagram. So imagine you are the body. Again, you're not focusing on the spring, you focus on the object. So the object, then you draw the axis. The axis, my recommendation, always follow the surface. So you see the two blue line there. Okay, one is along the surface, one is perpendicular. Okay, once you have the object, then you draw the straight line. That one is for gravitational force. Gravitational always vertical direction. That is for, again, go from the center of the object, draw W. Draw W. So just now, in the lecture, you see what can create work. Force can create work. Weight can create work. Spring can create work. So you have three components that create work. Okay, then there's a 30-degree from the surface. All right, 30-degree. What else? This one always forget one. Contact force. When you see anything contact, whether it's smooth or not smooth, they always have an end there. So start from chapter 2, you need to pull out the end, always. If you hear already, so no matter how you change it, you just follow the angle, right? So what else? Spring force. How do you draw the spring force? Okay, this one P follow lah. How do you draw the spring force? You attach first, attach your body, and then you follow the P direction. So when you try to imagine the P is pushing, pushing up. So you're reversing. You're reversing, so what you feel for your body, you're actually pulling out the force, right? So the force is pointing down. You imagine you are the block, so you attach to a spring. So when you're pushed up the slope, you actually feel the spring pull you. Right? So the direction is pointing down. Make sense, huh? Okay. That also 30-degree. You put an angle there between the P and the spring. Okay. So for chapter 3, again, when you draw free body diagram, because you're dealing with work, always check, have you drawn all the force? Have you considered weight? Have you considered spring force? These are the three. And then the careless mistakes normally is the normal force you forget. So contact force is very important. Whether you use it or not, that is another matter. Okay. So for example, this diagram 1, 2, 3, 4. 1, 2, 3, 4. It will give you 2 to 3 marks. So if you miss this one, maybe -1 mark here, and so on. Okay. So we will work on the. Okay, this one you know lah. This one already derived, but basically you can either use this one or you just remember force must go parallel to create work. Either this one or you just derive from your diagram. So we will just use there. So P will create work. P will create work when you move parallel to the surface. So you split this one into Y and X direction. When you split your P, the one that go down do not create work because perpendicular. Then you go to this one. So how to find this one and this one is cos, right? Cos component. So P cos theta multiplied by the distance traveled. So the total distance is what? 2 meters. Right? You move 2 meters, I already tell you already. 2 meters. Okay? So you do the same for other force. There's a spring force. There's a W. Does N create work? Although your free body diagram, there's an NB. There's no work created by N because it's always perpendicular to the surface. So if you're following force, you always convert force or you fix force, then you have trouble already. So my recommendation, always focus on the path, follow on the surface rather than the force. Fix your track. Fix your track, then you convert all the force along the track, then you get the answer. Okay, so I do the other things. So you press the calculator, you get one number. You do the same for other things. So initial position stretch is 0.5. Final position is 2.5 meter. How to get 2.5? The total you stretch 0.5 means the spring move 0.5. Then it will move to the end position is 2 meter, but you already stretch it already, so 2.5. Okay, so you need to put S1 as 0.5, S2 is 2.5. Okay, so again the equation for spring is half, again negative, negative half spring at second location minus the initial position. Okay, so when you plug in the numbers, you get negative value for spring. Okay, this one you copy later. As long as you understand the principle, then you're okay. In the test, all these numbers or the diagram will change also. Important, you know, okay, how do I find the work for spring and so on. Okay, the still concept still the same. Force must go parallel to the surface, then only can create work. Same with the work, with the weight. So weight, you can split into two directions, Y and X direction. So along the surface and the Y direction. Y direction, we are not very interested, but we go to Y direction. So again, in this direction, in this case, why? Why? Later. You understand how to get that one, right? Okay, later. Now we go to work first. What is the work done by the weight is positive or negative? Negative. I mean, before you do, you already know what is the value already. Okay, so you split the work into sine 30, then you get minus, right? Because the distance traveled is 2 meter. Same, I mean, the concept is you put the force and the distance together, and you get that one. Okay. Okay, normal force do not, contact force N do not create any work because it's always perpendicular. So actually there's working there. You just write normal force 0, also got mark 1. You write this one, got mark 1. You do not write this one, you will less 1 mark in your final mark for that question. You miss 1 mark if you do not write 0. Yeah. All right. Now, total work, you sum up all the things, all the energy or work is 500 something. Okay. So just to summarize what is actually happened in example 1, you just look at the question and then identify what are the force involved in the process. They are external force, they are spring force, they are contact force, they are contact force and spring force. Okay, but normal force always give you 0. Okay, again, normal force, you write work done by the normal force is 0. This is a bonus mark. Okay, you write this one, you get 1 marks. Okay. Okay, we go a little bit more. So principle of work and energy. So like what I briefed you previously, Principle of work and energy, if you look at if the question asks you, use your understanding in principle of work and energy, find something. It means you only look at work and energy. Okay, you only look at two things only. So work, we already go through the one example just now. Energy, you only do with two energy. Yeah. Okay. So this one just a derivation. And from the force, if you see a collinear motion like what you see on the screen here, you have tangent and normal direction. So this is just a recap of what you learned in chapter 2. So you have force in tangent direction, and then the particles is moving. If the particle move in acceleration, then you create force. M multiplied by acceleration, you get force. Okay. So this is how you derive lah. How you come to derive to half mv squared. This slide is just to show you how to get half mv squared. So you know that definition of A is dv dt, or A, yeah, this one is A ds equal to v dv, right? We derive from when we freeze the time. Okay, then we move the ds into another side. Then you continue integrate. Okay, continue integrate. You pull this one, substitute dt inside here. Then you move your ds to another side. So you'll get f ds equal to mv dv. Okay, you know that f ds is what? Is work. Force and distance traveled parallel, they create work. This is mv dv. It gives you work also. Yeah. So this is another new equation. So if you integrate both sides, so integrate f ds with s, and this side because you dv, so you integrate v. So mv dv, so v, you integrate, you get v squared of divided by 2. You substitute the value, you get this work done on the left hand side equal to half mv squared minus half mv squared. Velocity number 2, velocity number 1. Okay. So this is the equation. Then you know that you can split your tension, your force into tangent and normal. Okay, tangent and normal. Why we do not look at normal when we analyze for work? Why? Why? You know that collinear motion have two components, right? Normal and tangent. Why we are not interested in normal when we analyze for work? Why 0? Huh? Because it's perpendicular. Normal is 90 degree to the curve. And 90 degree one is it give you 0 work. So that's why when you do analysis for work, we're not interested in normal. Okay. So you just substitute the value there. Okay. You just arrive. This is the equation that we expect you to write in your answer sheet. If the question you see, please use understanding in principle, please use principle of work and energy to solve something. Write this equation. This 2 marks. You write this one without solving, you get 2 marks. You write all the work from station 1 to station 2 or point 1 to point 2 equal kinetic energy at station 2, kinetic energy station 1. So you write half mv square with the 2 there and half mv square 1 there. You write this one, you get 2 marks. or 1 mark minimum. Then you modify this equation according to the question. If the question give you position B, then you change this one to B. You change this one to A, for example. You look at the diagram, look at the question. Yeah, but again, this is the equation for principle of work and energy. Yeah. Okay. To help you to memorize during your revision, we will represent this equation with T to represent kinetic energy. So we write for principle of work energy, when we deal with motion with velocity, then we write work done by the particles equal to kinetic energy at station 2 minus kinetic energy at station 1. But basically, you write this one. Okay. Okay. So if you deal with a larger system with individual particles, you just sum all the energy together. Okay. You still use the same. You just write this one and then you try to solve. It's just a rearrange of equation. So if you see the question mentioned principle of work and energy, and you see the object is moving, so the first equation that we expect you to do is write this equation or this equation, same. This one or this one, same. Okay. Right. You can write the sum symbol here, sum symbol here, sum symbol here. Right. Yeah. All right. Now, just now we look at the velocity. Right. Now we look at friction. Does friction create work or not? Friction create work or not? Friction create work or not? What is the direction of friction to the surface? Parallel. No matter where you go, the friction force always create work. Because it's always go parallel to the surface. But to find the friction force, what you need normal force. Because friction equal to mu k n. So be careful on the direction that you analyze. So don't confuse with the normal. You need normal to find friction. You need friction to answer question using principle of energy. So I think you understand lah. When the object move on the surface, you have a friction force. Friction force friction force will give you negative work or positive work. Positive work or negative work? Negative, because friction always go opposite of your motion. Okay, then the rest you should able to understand already. So if you use principle of work and energy, you write what you write. U equal T2 minus T1, right? So this is just a derivation. Normally, the question will ask you what is your V2. So you rearrange the equation, or you can do the calculation for all the work. Then this one you write half mv2 square. This one you know mv1 square. This one you calculate. So work, you have a few. Work as long as your force and distance, they give you the energy. So force, spring, weight. In this case, normal don't create work, but normal will give you friction force. Friction force will give you work. So don't confuse with the normal force and friction force. Okay. So as what I write here, if you use this free body diagram, you arrive at half mv squared plus p plus friction force minus force and the v. Okay. Okay. Let's look at example number 2. So you have a car move in a 10-degree slope, and you're given an m. the mass of the object. Okay. If the driver jam the brakes, means you decelerate. Jam the brake means you decelerate. That means your A become negative already. Causing the wheel to lock. Determine how far the tire can skate on the road. The friction coefficient is given. Okay. So if you see this kind of question, how do you know this is a chapter 3 question? You're given coefficient. Of course, coefficient can be chapter 2, but how you know this is chapter 3 question? It always asks you what is the velocity before and after. Then it's chapter 3 question. Okay. Now, although you didn't, you can use chapter 2 to solve this problem by using F equal to ma equation. But of course, this example 2 is in chapter 3. If this one come out, this kind of question come out and force you to use principle of work and energy, then the question will mention force you to use chapter 3 equation. Okay. So you draw free body diagram. So you know the S traveled. This is from when they jam the brake. That is from the stop, right? So when jam the brakes, it asks you to find how far it can skid on the road. Means you know your final velocity, right? 0. So here you know your final velocity. You don't know your early velocity, right? You given early velocity. So basically, this one is force and distance. So in this question, distance is missing. Velocity is given. So there's one unknown there. Yeah. So the rest you just fill in the blank there. So W always go down 10 degree. There's a contact surface with N. Again, N doesn't create any work, but you need N to find what? Friction force. Okay, where's the direction of friction? Opposite the motion. Draw all this. By now, you should already able to generate the free body diagram by looking at the motion. Okay, so no spring, weight already given. External force, there's no external force because the car press on the pedal and engine do not create any forces, right? So you just do analysis based on here. Okay. Okay. Now, when this is just a short question. Ask you why the weight create positive work and not the negative like what we see. If you split this one to X and Y, so it's the same direction. Your weight goes same direction with your distance. So just be careful on the scenario. Go down can be different, go up can be different. Okay, don't think that weight always give you negative or positive. You need to work from your free body diagram. So this also the same. Okay, the rest you just apply equilibrium. So here you also can apply equation of equilibrium normal to the road because you want to find what is your NA. So you find all the normal force equal 0. So NA equal to your W cos theta equal 0. You find your NA. So you get your NA, one value. From NA, you find your friction force. From friction force, you find your work done by the friction. Okay. So here, you use principle work of energy because this question, the question itself is very general. You won't see this kind of question in your test or final exam. The question will mention very clearly, use principle of work energy to force you to use this equation. Will force you to use this equation. But again, this is one presentation. You can write all the energy and the work equal to T2 minus T1. Also correct. Okay, this is only one example. But some textbook they use this one. But in our class, as long as you write in the correct sequence, then you're okay. Right. So the rest you just substitute lah. Okay, so I don't need to explain lah. All this kinetic is half mv square. This is one. Then this is all the work done. So you only have a few work that go parallel to the surface, weight and the friction force. Weight and the friction force. Then the kinetic excitation number 2. You know the value of 2, right? 0. You know the value of V1. You know the angle. You know the friction force. The only missing is the S. Okay, so this is the concept on how you solve this question. Okay. Again, you can solve using chapter 2 question also. Why? Because acceleration is constant. Okay, this is just your homework. I just show you how to use chapter 2 solution, F equal to ma. So you just substitute based on the slope. So you get your A. Chapter 2, you need to find A always, then you find the force. So here, because it's constant, you can use the 3 Newton equation. In this case, you want to find the S, the distance traveled. So you have the V, you know the acceleration, there's one missing. So use this equation, you still find the same answer, also 5.76. There are two methods, but look carefully. The question asks you to use what? If the question forces you to use principle of work and energy, you have to use, you have to write all the work equal to T2 minus T1 and half mv squared. Right there. Okay. So example 3, I will just go very fast, but try to observe the way we solve it. So you have a crane, it's an application problem for civil, right? So you move a crane, a steel, and the crane lift 2.5 megagram beam. So remember to change to unit SI. Megagram change to kilogram. Your test 1 or your test 2 or your final exam, you'll get megagram. Force here is changing. Force here is changing in kilonewton. Kilonewton. Remember that. Determine speed of the beam when it have risen 3 meters from the ground. Also, how much time does it take to attain this height from rest? So you given V, you given you want to find the final V, where this kinetic energy come in, right? Then what else? We have the force. So you draw three body diagram, right? So free body diagram is what? Is the beam. Okay, so this one, you start with the boundary condition for the force. So you have two forces there. One is when at the ground. So S0, you substitute inside there because your force is depending on the ground location. So if it's at ground, force equal to 28 kilonewton. Then you check your weight, right? You check the weight. The weight is mg. So m is 2.5 megagram. So it's 2.5 kilo, 10 power 3 kilogram, 9.81. You get 24 point something. So the force when at ground and the weight pulling down, there's a lifting force. Means the thing can lift even at the ground. Okay. Yeah. So if the pulling force is more than your weight, then there's a motion already, right? Okay. So one, we do analysis, we do free body diagram. You draw the beam with the cable, force and weight. All right, force and weight. Okay, lifting force does positive work because the object going up. Okay, work, the distance traveled is go up, force go up, weight go down, give you negative work. Okay, use principle of energy. Again, write the work done equal to kinetic energy at station 2 minus kinetic at initial. Okay, you put in all the parameter. So kinetic half mv square. Work, in this case, you have two component doing work, force and weight. And then there's no spring, there's no friction force, right? So only have work and weight. So work FDS, WS, right? Only have positive, negative lah. Then half mv square. So once you do that, you know that it start from rest, so 0, cancel. Again, in your solution, you can just draw an arrow. Draw an arrow, we write equals 0. Then substitute the value. Force is equation. Substitute force here. All the value is given. So there's only one unknown, which is the distance. You're solving two. You get one equation, v equal to something else. You have two unknown here, but you still cannot solve the question. You need to use one more equation, which is substitute the s is given here. The final location s, so substitute here, you get your v. Yeah. The whole question actually asks you to use principal work of energy. Then you derive the energy here. So only three things that in chapter 3: external force, friction force, spring, and gravitational W, weight. These four things will give you work. Normal, you need normal to find. Normal do not create work, but you need normal to find friction. Okay, that is the things that I want to highlight. Okay. Then time, right? Once you have the V equation, you pull out chapter 1 definition for V equal to ds dt. You put inside here, then pull the S one side, pull S to one side, pull T to one side. It's a very lengthy equation, right? It's a integration question, mathematical question, right? But for engine dynamics, it's just this one, this section. V equal to ds dt. You find the V, then you rearrange the equation to find the T. Okay, it's a lengthy equation, right? The lengthy equation. Do homework lah on how to do this one. Okay, example 4, also your homework. I won't discuss in deep, but all the answer is there, right? It asks you to find speed when it reach B and the normal reaction as light exerted on the ball at this position. So this one is a curved motion. So again, you have tangent and normal direction. Okay. So you see the workout. So draw free body diagram, normal and tangent, and then what are the force that can act on the body? It's gravitational force, right? So at B, this is at somewhere along the slide. This is at B. When at B, the weight go with the NB. Yeah. So there are two scenarios. Okay. Then you just apply the principle of work and energy. So all the work done equal to the change of kinetic energy, 2 minus 1. Substitute the value, right? You find the missing parameter, it is VB. Or you can use equation of motion. This is the first one, VB, by using principle of energy, or you use chapter 2 question. It can become chapter 2 question. So equation of motion, again, this one, if you use equation of motion chapter 2, normal, acceleration is normal equal to V square over rho. In this case, you don't know the rho, you need to calculate the rho by differentiating this one 2 times. Substitute, then fill in all the value. You're going to find thing. So when you find the row, substitute inside there, you're still able to find the NB. So there are 2 methods involved in chapter 3 question. It can be chapter 3 and chapter 2 go in the same way. And how you know that it's chapter 3, it will force you to use principle of work energy equation, right? That's the only difference. 5 also same. You look at the datum, look at the pulley there. You already know. Pulley, you look at pulley. First, you look at the pulley system. First, you go and find the total length first. The total length, then find the velocity between A and B, or acceleration between A and B. Okay. Okay, then it tell you distance of B traveled. Determine the distance B traveled when it released from rest to the point where speed become 2. Here, your SB got 1, 2, 3, 4. So once you pull A, actually is you move 1 meter, you only move quarter of the value. You move 1, this one quarter. That is the ratio that you need to remember. Okay, so this one also you go through the slides. Okay, go through the slides. You'll find the answer. This is your homework. So all the answer is there. So if you don't understand this one, you can come to me and ask me why you get the answer. Okay. Okay. Power and efficiency. What is power? You know the work, right? You know the work. Okay. You know the work. If you take work divided by time, you get power. Get work. Okay. I think we stop here. I think we stop here. This is week 6. Next week is week 7. Your test is in week 8. So we still have time for another half of this chapter.